Good afternoon.
Good afternoon.
Tell us about your academic background.
I just finished my bachelor's from Ramakrishna Mission Narendrapur Residential College, and I'm currently trying to pursue my master's from uh, any of the top tier institutes.
Okay. Do you appear in any other examination?
Yes, I appeared in JAM.
Okay. Can you share your performance in JAM?
Yes, I scored 30.33, and my rank was 59.
Oh, okay. That is interesting. So, choose a topic between real analysis and linear algebra.
Okay, okay.
Hello.
Hello.
I am asking that give me a topic between real analysis and linear algebra.
Uh, I would pick linear algebra.
Okay. So, you know about eigenvalue and eigenvectors, right?
Yes, I do know about that.
Uh, Do you know what is geometric interpretation of eigenvalue or eigenvectors?
Yes, when we do a linear transformation, like we are moving the space from uh, from like we are transforming the space. While we are doing this linear transformation, there are some vectors which doesn't move. I mean, move from the their directions remain same. Their magnitude maybe gets bigger or lesser. That value of that magnitude is called eigenvalue, and which vectors doesn't change their directions. That vectors are known as eigenvectors.
Okay. Okay. Now consider you have two matrices A and B. They are symmetric. Okay.
Okay.
Then will A be symmetric?
Then will A be symmetric?
Yes. A and B is square matrix of same order.
Okay. Okay. Hmm. Can I use the whiteboard?
Yeah. Oh, yes.
If possible, can you show us the working?
Yes.
Okay.
It is okay.
Yes. Yes.
Yeah.
Thank you. Mhm.
Are you trying to construct any counter example?
Yes, I am trying to construct a counter example. Um, like a uh, at this point, 3 cross 3, I think it will be symmetric.
Okay, so you are thinking that it will be symmetric.
Yes, I am thinking so.
You can try for 2 cross 2.
Yes, it is coming out to be symmetric.
Okay. For 2 cross 2, it will be always symmetric, right?
Yes, for 2 plus 2, it will be always
Like
symmetric.
I am giving you a matrix, right? I am giving you 3 cross 3 matrix. Right, row wise. Okay, 1 0 0.
Okay, 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 okay. Wait.
Keep the whiteboard on. Okay.
Okay, okay. 1 0 0
And the rests are 0.
0 0.
And
Okay,
write another matrix, 0 1 0
zero 1 0
1 0 0
1 0 0
and 0 0 0.
0 0 0.
Okay. So
Oh,
A and B both are symmetric.
yes, yes, both are
And
symmetric.
what is AB?
What is AB? No, AB is not symmetric.
Okay, then it will, in general, it will not be symmetric, right?
Yes, yes. In general, it will not be symmetric.
Okay, now proceed to the next question. You know about vector space, right?
Yes, I do know about vector space.
Okay, so write a set, start with the
Right.
set notation, x comma y,
S equal x comma y.
uh, and the conditions are x plus y, xy belongs to real and x plus y less than equal to 1, and x square plus y square is equal to 1.
X comma y belongs to real
Okay? And x square plus y square is equal to 1.
equals to 1.
Yes. Is it a
Okay.
vector space?
So if we take 2 points like x curl equal to x1, x2, and y curl equals to y1, y2, both belongs to S, then we will be checking x curl plus alpha y curl either belongs to S or not.
Okay.
Then x1 comma x2 plus alpha y1 plus sorry, alpha y1 comma alpha y2, 1 x2 plus alpha y2, and we have that x1 plus x1 plus x2 less than equal to 1 and y1 plus y2 less than equal to 1. x1 plus alpha, oh sorry,
Sorry for interruption, but
yes,
uh, what is alpha?
Alpha belongs to real number. Actually,
If I
huh?
do not,
Yes.
if I do not specify the field, can then can you say anything about alpha?
If we do not specify about the field, we cannot. No, we can't
Okay,
say anything about
okay.
alpha.
Then take real number set as field and
Okay,
then
okay.
okay.
So taking our field equals to real number, alpha belongs to real number. Then x1 plus y1 plus alpha into x2 plus y2. This does not necessarily will be less than 1, because if we choose alpha so big, it can be greater than 1.
Okay, then it will be a vector space or not?
No, it will not be a vector space.
Okay, okay. But do you need so much of work to say this?
um
Can you say something in one line?
if we look at this condition, we can easily say that, because we will be doing linear transform, I mean, this linear operation we will be running, and this is not a linear, so this will obviously not be a vector space.
Okay, but
I
if we give you, I mean, delete the restriction x square plus y square is equal to 1 and just take x plus y is equal to 1. Okay,
x plus y equals to 1,
yes,
then it will also not be a vector space because of this alpha.
okay, okay. That is right. This procedure is right, but I am saying
Oh,
another thing. Note 0 comma 0 belongs to s.
0 comma 0 no, does not belongs to S.
Then s cannot be a vector space, right?
Oh, yes, yes, yes.
Okay,
I got
that
it.
is the thing. Okay. Now, little question from real analysis. Now consider you have a sequence.
A
Okay,
sequence.
two sequence x1, x2, which converges to x, and y1, y2, which converges to y.
This converges to X,
Uh, and y1, y2 converges to y.
converges to Y. Okay.
And you have the sequence, another sequence whose first term is x1, x1, y1, x2, y2, alternate.
X1, like this,
Yes, yes, alternate x1, y1, x2, y2.
X2, Y2. Okay.
Okay, where does it converge?
No, it will not. It will not converge. It will converge if X or Y are same.
Okay, can you prove that?
Uh, we have a statement like, if a sequence have more than one limit point, then it is called divergent.
Mm,
From that, I can say that
I am
this
giving you that statement, right? So I am asking that do you know the proof of that statement?
sorry,
I what I am saying that what I gave you basically
uh,
that thing and the statement is same, right?
yes, yes.
So can you prove the statement?
uh, Actually, I forgot that proof.
Okay, that is not a problem. And okay, last one question from linear algebra. Do you remember dot product?
Yes, I do remember dot product.
Okay, right, right. You have two vectors x curl and y curl, uh,
X curl and
and
Y
y
curl.
curl, both from real number x curl and y curl from Rn. Okay,
Okay, okay.
and length of x curl is 3
Length of X curl is 3.
and length of y curl is 5.
Length of Y curl is 5. Okay.
I want to know about length of maximum and minimum length of x curl plus y curl.
X curl plus. Acha. Okay.
First, give me the intuitive answer when it will be maximum or minimum. Then we will proceed mathematically.
You want maximum value of this.
Yes, length of x calculus.
We will use triangle inequality for this.
Okay. Okay.
So maximum length will be 8
Okay. And minimum.
and minimum skull plus minimum length and
First, try to visualize it. Okay. Then you will understand when it will be maximum and minimum.
okay.
Uh, the shorter one is x cal and the another
Yes,
is y
yes,
cal. Then what
yes.
will when this 8 appear?
When this will be
Max.
minimum.
Okay. When first tell me when it will be
Oh,
maximum.
the minimum value should be like 5. If x color and y color are the same, then then it will look like this. The minimum length should be 5.
Can you prove that?
Can I? Um, no, I do. I don't think I can.
Okay. That is from my part. Okay. Thank you.
Okay, Suprodip, can you please clear the board?
Obviously. Can I just move from this side?
Sure.
Thank you.
Okay. So my first question to you is, suppose x and y are two random variables.
X
Does
and Y.
yeah,
Okay.
does covariance between x and y equal to 0 implies that x and y are independent?
No, that does not implies X and Y are independent because covariance measures linear correlation between the random variables.
Covariance measure,
A linear association between the random variables.
yeah, linear relationship between the variables, right?
Yes, yes, yes.
Okay. So is it never true or sometimes true for some cases?
Uh, it is like covariance equal to 0, and
Implies
that
x and y are independent.
no, it is sometimes it is true because when they are linearly dependent, then some cases the covariance becomes 0.
Can you figure out some distribution for which it hold?
We can take the multinomial distribution where summation of pi less than equal to 1.
So
Uh, uh, in that case, the covariance. No, no, no. Sorry. If we take any independent, if we take x, sorry, x follows normal 0 comma 1, and y follows exponential 1. If we assume that these two random variables are independent, the covariance will be 0.
No, that is something independence imply covariance zero. That is always true. I am asking that covariance zero, does that implies that they are independent?
Covariance zero, does that imply? Uh,
There are two things. Independence imply covariance zero,
yes, yes,
and
yes, yes. I
covariance
understand that.
zero, do that imply that they are independent?
Uh, if we take a bivariate normal distribution, normal
Yes, that's a correct example. If the
biva-
correlation is zero there, then they are independent.
yes, 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 yes.
Can you intuitively tell why is it so?
Uh,
Take the example of bivariate normal only.
mu x, mu sigma square x, sigma square y, and rho. So your question is the intuition behind it.
Yeah, when rho is zero, they are independent. What is the
Um,
definition of independence of two random variables, x and y?
uh, x comma y are independent if their joint distribution can be written as a product of their distribution.
So, do you claim that for all xy, it has to be for all x?
Sorry, this should be the distribution function. Ye- yes, if this can be written, they are these two distributions are independent.
I guess it will be for all xy. That's the complete definition.
Yes, 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 for all x comma y.
You can do that. Okay. Yeah, that's okay. Now, but actually, we generalize the definition in terms of CDF because there are many random variables which are not properly discrete or not properly continuous. But in case of bivariate normal, it's absolutely continuous. So
Yes.
you can take that PDF also.
Okay. Okay. Okay.
So you have written if. So that's a sufficient condition. Is this also a necessary condition for independence?
Mm, yes, this is a necessary condition. If this holds, then x and y will be independent. If and this should be if and only if.
Yes. And you are telling that covariance zero implies x and y are independent.
Oh,
This you are taking the example of bivariate normal.
yes.
So, do there exist any another distribution for which you can claim this thing?
Uh, as of now, I can't remember any bivariate distributions. I have studied only bivariate normal and multinomial distribution and nothing further.
Okay. So so we came to the conclusion that covariance zero implies x and y are independent for bivariate normal, but
Yes.
um, it's not always true for any sort of other distributions. Can you give me an example, counter example of, say, one discrete and one continuous variables where x and y are, say, not independent, but their covariance is zero.
But their covariance is zero.
One discrete and one continuous.
The discrete can be done by just doing this. X takes values. Suppose minus 2, minus 1, 0, 1, 2. With probability, I say 1 by 5, 1 by 5, 1 by 5. And y takes values 4, 1, 0, 1 4 with same probabilities, 1 by 5, 1 by 5, 1 by 5, 1 by 5, 1 by 5. Here we can see that there is a perfect relation between x and y, which is uh, y equal to x square. But if we calculate the covariance here, x and y, this will came out to be 0. Hello.
So, what can you conclude from this? That y and x here are not really, I mean, covariance is zero implies that there is no linear relationship, right?
Yes, yes,
There
yes.
may exist some other sort of relationship. This example portrays that, right?
Yes, yes, obviously.
Okay, that's perfect. So, now the continuous part, you have to
Continuous
show a
part.
joint distribution in which
Okay,
x and y are, say, dependent. Okay,
okay. If
but
we take a distribution, say a uniform distribution over a circle, the I am
okay,
writing
okay,
down
that's
the.
all right. You don't have to do that again.
Okay,
Yes,
okay,
yeah, that's a perfect example of that. Yeah, that you can do.
okay, okay. Thank you.
Now, suppose I have one standard normal random variable as you have written here, x, right?
Yes, yes.
So, can you tell me by squaring it, we will end up with which distribution?
Can I derive that?
No, you can tell me if you know.
Mm, I forgot. I forgot. But
No,
I
that's
can derive that.
a simple thing. You just think once. It's a standard normal. I just want to square it.
It's a standard normal. If I square it, I think we will get some sort of exponential or gamma. It is.
That is a particular type of sampling distribution. There are
Oh,
three.
no, normal square. Chi-square 1. Sorry, sorry. I
Yes,
just.
that's a simple
It,
thing. You don't need to derive it for that.
it just got out of my head.
Okay, okay, okay. That's okay. Now, my question is, can you square up any non-normal variable to obtain a chi-square distribution? It's a chi-square 1, right?
It's chi-square 1. Yes.
Okay. So, can you square up any non-normal distribution to end up with a chi-square 1?
Square any non-normal distribution. Square of any non-normal distribution. No, I can't think of it right now.
It's very easy. Just try to think. The answer is itself in the board. You have to just have to play
Square
some mathematics.
square of any non-normal distribution to end up with chi-square distribution.
Chi-square 1 distribution.
Chi-square square of any non-normal exponential one.
No, never.
Exponential
You have to square that, remember.
uh, two I have to square that, and then I am not getting anything.
Okay, so let me tell you. Uh, so x is normal 0 1, suppose.
Okay.
Here you have already written that. Let me
uh,
mark it.
X is
Suppose
normal
you take
0.
the mod. Can you tell me what sort of distribution is it?
It will be a truncated normal.
Truncated or folded?
Folded normal.
Truncation means you are omitting some part of it, but here you are, I mean, by taking the mod, you are precisely taking the right hand side of, I mean, right hand side of the zero.
I think that when we are taking mod, we are just truncating the negative part. So that's why I told truncated normal.
Yeah, that's, yeah, let's not get into that. That's two statement may be
Okay,
equivalent for
okay,
our case.
okay, okay,
So that is known as some folded normal, right?
okay. Yes,
That is
obviously.
not normal anymore. But if you square it, will you end up with chi-square 1?
Yes, I will. I will end up with chi-square one.
Okay. Did you get it?
Yes. Ah, yes, I get it.
Okay. So now chi-square 1, can you comment on its symmetricity?
Chi-square one is a
Any
uh,
chi-square n say, any chi-square n say, can you
uh,
comment on its symmetricity? Not symmetricity, but skewness, say.
oh, skewness. Chi-square is a positive skewed distribution.
Yeah. Okay. So, do you know what is the? I mean, we have learned for AMGM inequality, right? AMGM HM inequality.
Yes,
So
obviously.
we have done it for data. Now, can you state AM and HM inequality for a random variable?
I didn't get your question. Can you please repeat?
Sure. So I am telling that we have studied AMGM HM inequality,
Yes, obviously.
but for a random variable which is non-negative, more precisely positive valued random variable, that is probability capital X greater than 0 equal to 1,
Okay.
state the AM HM inequality, arithmetic mean and harmonic mean inequality.
Yes, we can take the AMHM inequality.
Can you write that for me?
Like
For
AM
a random
greater than
variable,
equal.
what is the arithmetic mean? That's the expectation, right?
Yes, obviously. For a random variable, AM equals to expectation of X.
Yeah.
Sorry. AM equals to expectation of X, and HM 1 by expectation of 1 by X.
And what's the relationship between them?
uh, AM greater than equals to HM.
So it's a, can equality hold here, or it will be a strict inequality?
Equality can hold if the random variable takes only one value, but if it is a continuous random variable, it will not take just a single value. So I think the equality will not hold here.
So AM is precisely greater than HM, right?
Yes.
Okay. So my next question: consider a f m comma n distribution.
uh, if m comma n distribution.
Okay. Without deriving the exact expectation of this quantity, you know that what is the expectation of f of m comma n?
Yes, I do know that.
That is n by n minus 2, right? When n is greater than 2.
Yes,
So that is something which is greater than 1, right?
that is yes, yes, obviously.
Of course. So now derive the my claim is expectation f of m comma n is greater than 1. You have to prove it without deriving the expectation of f of m comma n.
Oh, uh, I should. If we use this inequality, and we know that 1 by x follows f of n comma m, can I use the result expectation of f of m comma n equals to n by n minus 1, n minus 2?
No, if you are
Oh,
using that, then you can say that.
okay. Yes, 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 yes. I got it. 1 by x follows f of f n comma m. Uh, m greater than equals 1 by x.
You can tell me if you need a hint, right?
Yes, hint would be helpful.
Try to write f of m comma n as division of chi-square, independent chi-square random variables.
Okay. F of a square by n. So, uh,
Now they are independent, right? Chi-square m and chi-square n. Now
yes, yes, obviously.
use all the facts
So,
that you have
okay,
written on the
okay,
board to derive.
okay, okay, okay. Expectation of chi squared n by chi squared n equals to expectation of chi squared n to expectation of 1. And we know that expectation of chi square n must be greater than expectation of 1 by chi square n, that will end up expectation of 1 by chi square n.
No, no, no. What you have written here, here in this step.
Am greater than equals to hm inequality I used.
Okay, so
So expectation of chi square n is greater than 1 by expectation of 1 by chi square n.
yeah, okay, you are on the right track.
Can I proceed?
Yeah, sure.
So from this we can say that expectation of f of m comma n equals to uh, sorry greater than expectation of chi square m by expectation of chi square n into n by m, which is equal to 1.
So that's the intuitive idea to prove this claim, right?
uh, yes.
Okay, now my next question is, suppose you are having a coin, right?
A coin, okay.
Okay, and the coin can, if you flip that, either it will be head or it be tail.
Okay.
Statistically, these are the two main things that we usually consider. But in physics, we learn a popular phenomena, like there are many things like the thickness of the coin and some sort of biasness that you can make with the coin, which may end up with the landing of the coin on its edge, right?
Okay.
In statistics, we consider that probability as zero.
Yes, obviously.
Okay.
Hmm.
So, can you simulate this process, entire thing, that whether it will be a head or it will be a tail, or whether it will land up with the coin will land up on its edge by using some sort of distribution, continuous distribution?
By continuous distribution.
Yeah. And suppose I say that the coin is unbiased. Okay,
Okay, the coin is unbiased.
head and tail are equally probable.
Okay, I understand that. If there is only three possible outcomes of this random experiment, how can we stimulate this using a continuous random variable?
Try using uniform 0 1 distribution. Simulation means what? It is an imitation of a process, right? I mean, you will do a process that is equivalent to it.
Okay. In this case, I have to consider that the coin will end up in a straight position.
No, you have to simulate the entire process. You
Uh,
have to simulate all the possibilities. Suppose you flip the coin, whether it will come head, whether it will come tail, or whether it will land up on its edge.
okay, if we consider a random variable x, uh,
I have given you a hint, uniform 0 1. Try to use that.
um, uh, can you please give me another hint?
Okay, so what are the probabilities of obtaining head, tail, and landing up on the edge?
Um, but you just said that if the coin is unbiased, we generally take the probability of getting a head is half, and probability of getting a tail is also half.
Correct?
And we don't take the outcome of that experiment that the coin is landing straight. I mean that the probability is we take that probability as zero.
Yeah. So can you find out? So, so that's the answer. So you have to find out these three probabilities using that random variable, right?
I have to find these three probabilities using that random variable.
Yeah, by the
Uh,
decision. Based on that X, you have to take some decisions so that these probabilities are made. So you can say that my decision is equivalent. So you will end up with three decisions, right? There
yes.
are three probabilities. You will end up with three decisions. So three
Okay.
decision will correspond to that all that three outcomes. That head, tail, and landing of a coin on its edge, right?
Okay.
So then you can tell that my decision is equivalent to this head, my this decision is equivalent to this tail, and my this decision is equivalent that it will not land up on its edge. So that's the
Like
imitation.
if we are drawing a random sample from uniform 01,
Not a sample. I have used
drawing
only
a
one of the
single
sample.
random number,
Yeah, okay.
uh, like if say x is the random number, random number between 0 and 1. So I can say that 0 to half is uh, is equivalent to getting a tail, getting half is equivalent to landing on both side, and half to one is head. Is that what you are talking about?
Yeah, that's the answer. This
Sorry, I didn't get the question still now.
Okay, so not only head or tail, if you have to choose surely one person between one or two, you can use that method. I mean, in simulation can be done in many ways, right? But in statistics, if you have to simulate one event, you have to necessarily you have to create something with the random variable, and you have to create some event with some random variable, and you have to necessarily show that the event that you want to simulate, that probability, and the event that you have constructed using that random variable, that probability, both the probabilities are same, right? This is
Okay,
exactly what we have to do. So
okay,
that's
okay,
that's the thing. Okay. So that's all
okay.
my part. That's all from my part. Okay.
Thank you.
Okay, so suppose x1, x2, xn is a random sample from uniform minus theta comma theta.
X1, X2, Xn from uniform
Uniform
minus
minus
theta
theta
comma.
comma theta.
Okay,
Yes. So find the UMV of theta by 1 minus theta.
fine.
UMV of theta by 1 minus theta.
By one.
Yes.
Um, the sufficient stat for theta is, this is a sufficient statistics for theta.
Hello. Okay. So is it sufficient for theta from the distribution that I have given? Will the
Yes,
minimum not depend on the on theta?
if we take this, take the mod, then this will be sufficient.
Yes. Okay. So oh, you have written mod. Acha, acha. Okay. 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 Yes. 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 No. Okay. Okay. You can proceed. Will it be complete?
Yes, this will be complete sufficient. And
Okay.
if we don't take the mod, then the sufficient statistic will be x1 and x order n both. Then in that case, that
Yes.
it will not be complete.
Okay. Okay. Fine. Okay. You can proceed now.
So I am writing down this both. Okay.
Okay. You can.
Uh, expectation of and x order r follows beta 1 n comma 1 expectation.
What have you written there? X order R follows beta R
N
comma
comma
1.
n comma 1
Acha. X or N. Oh, acha. You have written N. Okay. 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 It's fine.
it is okay.
Yes. Yes, it's fine. It's fine. You can proceed.
Actually, I just I forgot how to get how can I get UMV. I am not in practice, so that's why.
Jeet,
Hello.
unmute yourself.
Oh, hello.
Hello.
Yes, so tell me the process basically. Like, why have you written that sufficient statistics when?
We like the process is the process is Lemon-Sheff theorem. If T is
Okay,
complete and sufficient for theta,
yes.
and
Then
H of theta H of H is unbiased. H is unbiased for this one.
okay. So H is basically based on the complete sufficient statistics.
Yes, yes.
That's what you
H,
want to say. Okay, okay.
yes. H is like expectation of H given T
Hmm.
equals to phi T. This would be UMVE of this thing G of theta.
This
I
will be the
if I
UMV of this thing. Okay, okay. So like, what does this expression will give you? Like H given expectation of H given T, it
this
will
will
be a
give a
function of
function
something.
of T. T means
Function of
sufficient,
T.
complete sufficient statistics of this one.
Yes, yes. So that means you are finding an unbiased estimator which is only dependent on T.
I think
Is it true?
there was a formula for phi t like g of t.
No, I
Uh,
don't know. I don't need any formula. I do. I just
okay.
to ask you that. Uh, so what you are basically trying? Are you trying to find an unbiased estimator based on the complete sufficient statistic? Is that true?
Yes,
Okay, so find it.
and
Do you
age.
get my point? Do you get
Yes,
my
yes,
point?
yes, yes.
Now find it. You know the distribution of x order n, like the mod of x order n, right? So use that.
Uh, what is the distribution of mod of x order n? I
Yes, you
think
have written, na?
that is beta one n comma one. Sorry.
Yes, yes, you have written that. You have written that.
N plus one.
Yes. Will it be n by n plus one? Look at the distribution. What will be the distribution of mod x?
Mod x is beta n comma one.
No, no, just what is the distribution of mod x? I'm not about mod x
Oh,
order n.
mod x uniform 0 comma theta.
Yes. So then look at your expectation. What you have written? N by n plus one. Is there
Oh, sorry,
anything
sorry,
else?
sorry, 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 sorry.
Yes. Yes.
And okay.
What have you written there? Expectation of x order n.
Uh, mo-
Okay.
uh,
Okay. 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 N plus one by n is equal to theta. Okay.
yes, yes.
Hmm.
And say uh, expectation of g of theta equals to 1 minus theta.
The expectation of g of theta.
Yes, actually,
Then
I
you
need
can
to.
define. Then you can define g theta equal
Oh,
to 1 by 1 minus theta. Why do you need to have any expectation? Your g is a function of theta, na?
yes, yes, yes.
So why
No,
do you take any kind
G
of
is not a
expectation?
function of theta. I am
Okay.
making.
Yes, yes. G will be a function of your statistics, right?
Yes, yes, yes. Sorry, sorry. and this
This will be
is
theta by 1 minus theta. This will be theta. Okay, okay. You have written theta there. Okay, okay. It's fine. It's fine. It's fine.
so
No, what have you written? G of x order n by theta.
yes,
You
mod
have
of
taken theta inside. You have taken theta inside that, inside the function.
because this follows uniform 0 1. That's why I have taken that.
No, but you are calculating expectation of g of x order n by theta. Like, is this theta inside the g function? So suppose
Oh,
expectation of g of mod xn is equal to theta by 1 minus theta. Okay. So
okay.
if you take theta in the left side, you divide both
Hmm.
side by theta, then
Hmm.
will it imply that g of x order n whole by theta is equal to g of x order n
Oh,
by theta? Like, can
oh,
you take
oh,
that inside the function?
no, 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 I can't take that.
Yes. So now what will you do?
And this follows uniform 0 comma theta g of.
Yes. So your parametric function will be in the left hand right hand side. Will it be 1 by 1 minus theta? The line you have written before, expectation of
No,
g of
no,
mod
I
of
can
xn.
take theta by 1 minus that will
Yes,
even
yes,
the.
yes, 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 yes. Just do that. Write down the PDF. Write down the PDF of x order n. You need the PDF of x order n, right?
Yes, 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 yes.
You have written the yes. Suppose I am giving you the PDF. The PDF will be. Do you know the PDF?
Yes, yes, I do know that.
Okay, okay, okay. Then proceed. This is the PDF of x order n by theta. Okay.
Okay.
So the
Then
PDF should yes, yes.
then
So
I
then
will
and
derive
here
it.
you need the but here you need the PDF of x order n, like the
Okay,
mod
okay.
of x order n. Okay.
I
So this
will.
PDF will involve the parameter. So suppose I am giving you the PDF. It is n by theta to the power n. Write it.
Yes.
Suppose it's n by theta to the power n.
That's it,
N
I
by
think.
just reverse. Just reverse. It is just the reverse. Write it. The PDF. It is n by theta to the power n. X to the power n minus 1. X just x to the power n minus 1. Yes. X will belong to 0 to theta. Okay. Support is
Zero.
0 to theta. Yes. Now write it. Now do it.
Mm.
Okay, now you just have to differentiate and you will get the answer, right? So you don't have
Yes,
to do the
yes, yes,
calculation. Yes,
yes,
you
yes,
just
yes,
have to differentiate and you will get the form. Okay,
yes, yes.
so now can you find the MLE of this quantity?
MLE of this quantity.
Yes, theta by 1 minus theta.
Uh,
This is very easy. You can answer it.
oh, yes. If I get the MLE of theta, then by the property of
Yes,
invariant, by the
invariance
invariance
property.
property,
Yes.
we can get the MLE of this.
So what will be the MLE of theta in here?
MLE of theta would be. Uh, can I write down?
Yes, yes, you can write.
F of x theta.
So you can take like the mod. You can take the mod also. There will
Okay.
be two MLEs. One will be based on this sample, the other one will
Uh,
be based on
yes. Then the MLE will be x order n, mod of x order
mod
n,
of x order. Yes.
and the
Okay.
MLE of theta by 1 minus theta should be mod of x order n by 1 minus mod of x order n.
Hmm. So basically the two MLEs are same. If you
Uh-huh.
proceed in that way, like two MLEs are basically the same. Okay.
Yes, yes.
So now my question to you is, you have got an UMVV, you have got an MLE. Now what you will choose between them
Okay,
to
Jeet,
estimate?
just interrupting. You
Okay.
have written here mod x order n. Is this the correct way to write it? Because what is
Yes.
necessarily the sufficient statistics is maximum of mod x1 to mod xn. So
Yes, yes.
maximum of mod x1 to mod xn, is that similar to say mod of x order n?
No, this can be different, because if we have a negative magnitude higher than a positive, then we will
Yeah, you
yes,
can
yes, yes,
check. Suppose you are taking the data as -2, -1, 0, and 1.
yes,
X
yes,
order
yes,
n
right.
is 1, but maximum of mod of them is 2, right?
Yes, yes, yes,
Okay, so
yes, thank
Just
you,
change
thank
the
you.
notation. Just change the notation. That's all.
Should I write it like this?
no,
Yes,
if you
yes.
are comfortable with, you can do that. I was just checking the idea. That's
Okay,
correct.
okay, okay, right.
Okay.
Okay, so now yes, so what will you use now? Will you use the
uh,
UMVV or the MLE for estimation?
Obviously I will use the UMVV,
Why?
because the UMVV will have minimum variance over all estimate of g theta.
Are you sure?
Yes.
So suppose the UMVV that you have got, I divide it by half.
You divide it by
Okay.
half. Okay.
Yes. So what will be the variance of that estimator?
1 by 4 into variance of UMVV.
That thing. So the variance will decrease, na?
The variance will decrease, obviously,
So
but
it is a better estimator
that
then.
will not remain unbiased.
Yes. Yes. So basically, what are you checking when you are estimating a parameter
Uh,
and you
Firstly,
are
we
estimating the,
check either this is unbiased or not. Then we check the variance.
is it the only criteria to check a good estimator?
Like if the variance is same, we can check for consistency.
No, I'm not talking about consistency. Like I'm talking that is to get a very good estimator, is unbiasedness necessary? Okay. If if I want a very good estimator, then
Yes, yes, I got it.
should it be unbiased? or there are some other criterion? I think you have read about the absurdity of unbiasedness also, right?
No, actually, can you explain what does that mean? If maybe I have studied, but
Okay, okay. So what he is telling that uniform minimum variance unbiased estimator, those estimators have the least variance, right?
yes,
Only under the class of an unbiased estimator.
yes, obviously.
Okay, but unbiased estimator may or may not be there. So what's the criteria you should use to check the goodness of an estimator other than that UMVUE criteria?
Do you understand what is my
Yes, yes, I,
question?
I, I did understand.
You have told about consistency. That's a large sample criteria, right?
Yes, yes, that's a large sample criteria.
For small sample, there is many.
Hmm.
So what we are try to minimize. Suppose in any cases, in any cases,
We are
what?
trying to minimize if the very estimator is not uh, unbiased, then we try to minimize the MSE.
Yes, yes. So will it happen that a bias estimator has like lower MSE than than an unbiased estimator? Can it happen?
No, it can't.
Why?
Because we have studied that expectation of x minus x bar, uh, that square is x, like expectation of x minus c square, it is minimized when c is the mean.
Yes, the when the C is the mean, but does like mean necessarily means unbiasedness? Like the mean will converge
Like
in probability to expectation of that random variable. Okay, when
okay,
the sample is very large,
when the
but when the
sample is
sample
very
is
large.
small,
Hmm.
when the sample is small,
Hmm.
will the mean and the expectation will be equal?
uh, for mean, implied expectation of x, this quantity should be minimized if c equals to expectation of x.
Yes, but what you are trying to minimize? You are trying to minimize x minus theta, the value of the true parameter,
Yes.
right? The value of the true parameter. So you are basically taking the difference. Your parameter
Hmm.
is fixed. It
Hmm.
cannot change, right?
Oh, yes, yes, I got it.
You are not placing any statistics over here. You are placing a parameter.
Hmm.
Like parameter can have a distribution, but as of now it is fixed,
Ah,
right?
yes, right.
So how can you claim that? There are example like if you suppose you are taking a normal samples from a normal distribution. Okay, you find the UMVE and you find the MLE and calculate the MSEs, and then you compare them, like which will be the whose MSE will be the lowest. Okay, you can
Okay, okay,
check that later. Okay,
okay, okay,
so unbiasedness is not a necessary criteria to be a very good estimator. Okay,
okay, okay,
and you can check the notes also, like there are some examples of the on absurdity of unbiasedness. Okay,
okay,
you can
okay.
check. Hmm. So that's all from my side. So do you have any question?
No, specifically, I don't have any questions.
Okay,
Okay, all the best then.
all the best.
Thank you.
Hmm. Okay.